Hopefully that matches what you have. Obviously, so please check your answers real quick and just, again, give yourself a score out of 4, and then be happy to answer questions. Numbers 3 and 4 are very new. Numbers 3 and 4 could very well be on your Unit 5 test. Actually, 2, 3, and 4 could all be on your Unit 5 test. So, good review for sure. All right, so now would be a fantastic time for you to ask questions. What do you have? Yeah, number 2 is has a couple of tricky things in it, no doubt. So with number 2, like I've mentioned before, I'm not really into the, hey guys, step 1 is this, step 2 is that. What I'm going to do here is I'm going to try to notice things that are important and useful, and then try to logically deal with them. So one way to do that would be to notice that this first set of parentheses is being squared, right? So if that first set of parentheses is being squared, think why not apply that squared to everything that's actually being squared, right? So I'm just going to go through factor by factor and try to square everything. So what's 4 squared?
16.
The popular answer sometimes is 8,
16.
but it's actually 16, right? It's 4 times 4. So I'll put 16 right there. And then how do I deal with x to the negative 2 squared? What do I do with the exponents there? Do I add them, subtract them, multiply them, divide them? What do I do? That's when we multiply. And if you're wondering about this, here's a way you could handle this. I'll erase this in a second. But isn't x to the negative 2 squared just x to the negative 2 times x to the negative 2? And when you're multiplying bases, what do you do with your exponents? You add them. So whether you split it out like this, or whether you just use the property, you'll get the same answer. The only problem with splitting them out like that is if it's x to the negative 2 to the 20th, it's going to take forever, right? So it's more efficient to understand the property and use that. So this would be x to the negative 4th. Then if I've got y cubed squared, isn't that basically just a y cubed times a y cubed? And how many do I have now? How many y's? 6 of them, that's right, y to the 6th. So again, I just noticed that I had the parentheses being squared there. So I thought, well, let's go ahead and square it. Let's see what we get. The second set of parentheses is pretty similar, but the fact that it's a negative exponent, of course, makes a pretty big difference. Here is where people do things that are just, I don't know, to be frank, just wrong and not logical. So here are some things that I sometimes see. They see, all right, we've got 3 to the negative 2. I'll see stuff like this. Do you see why somebody might do that? Never ever will we multiply a base times an exponent. We never do that. Okay, so here's the next popular wrong answer. Right? They're like, hey, 3 squared is 9, but there's this negative in there, so I better make it negative. That's not right either. Remember, a negative exponent doesn't mean that the base needs to be negative. A negative exponent means that the base needs to do what? If you see something to the negative 2, you flip it. Take it from top to bottom or bottom to top, whichever way it needs to go. So here's how I would write this. I would say, gosh, I'm not really sure what 3 to the negative 2 is yet. So you know what I'm going to write? 3 to the negative 2. And again, my encouragement to you is not like, hey, Mr. Anderson's 5 tricky steps to success. My encouragement to you is be logical. And if you don't really know what something is yet, don't overthink it, right? 3 to the negative 2, I don't know what that is. No big deal. Just write 3 to the negative 2. Just be logical. And then if I've got x to the 8 to the negative 2, the same kind of pattern as the first one, right? So this is where I'm going to multiply my exponents. And then y to the first to the negative 2, again, I'm going to multiply my exponents. My next step maybe would be to multiply the like bases. So I've got x to the negative 4th times x to the negative 16. What do I do when I'm multiplying bases? That's where you add your exponents. So x to the negative 20 for that one. And then I've got some y's, of course. I've got y to the 6th times y to the negative 2. Again, this is the scenario where I need to add those exponents up to make this make sense. So this would be y to the negative 4th. And the truth is, I'm really comfortable with 16, but I still am kind of feeling like, man, I don't know what to do with that 3 to the negative 2. I really want to write negative 6 or negative 9 or something. But I know that those aren't right. So instead of like making a hasty decision and being wrong, I'm just going to hold off until the end and until I can maybe clear things up a little bit. My final step is to try to handle the negative exponents. And this should be y to the positive 4, sorry. There we go. And this is finally, when I try to handle all my negative exponents, this is finally where I can handle that 3 to the negative 2. Check it out. What's the exponent on the 16? Not negative 1, positive 1, right? Remember, if there's no exponent at all, it's a 1. So, and 1 is positive, so I would say the 16 has a positive exponent, so it stays exactly where it is in the numerator. However, the x has a negative exponent. So instead of being in the numerator, we need to put it in the denominator. So I put over, then I've got x to the 20th. The y has a positive exponent. So where does it go? Stays right where it is. That's right. So y to the 4th stays in the numerator. And finally, I get to this 3 to the negative 2, and I think to myself, oh, okay, finally, I know what to do with this. If a base has a negative exponent, it needs to go from top to bottom or bottom to top. So that 3 to the negative 2 needs to flip down. So I'll write 3 to the 2. And then my final step would just be to write 3 squared is 9. So it would be 16 y to the 4th over 9x to the 20. I know that I'm done because every single exponent is positive, and I've simplified all the numerical bases that I can. I'm done. Again, Chase, that sounded so awesome in my head. How could somebody not understand that? But you might not have. I might have messed you up even worse. Do you have any follow-ups or?
No.
Made sense? Was it the 9? The 3 to the negative 2 was a struggle?
Yeah.
Okay, for a lot of people, that is a struggle. Just remember, 3 to the negative 2 is just 1/9, right? It's 1 over 9, but maybe it's best to handle it the way that I did up there. I don't know. Anybody else have a question on 2? Number 2. How about 1, 3, or 4 then? 1, 3, or 4? Isa? 4? Okay. So 4, it says solve. So of course, solving means that we need to get the x isolated is one way to think about it, or we want to figure out which numbers make the equation true. And so the way that we're going to do that, I think here the best way to do this, at least off the start here, is factoring. And I think maybe, I don't know, I might show an alternative method to finish this one. Is that okay? So whenever you've got some expression like this, where the degree is higher than 1, factoring very well could be the thing that makes the difference between failure and success. And if you're going to factor, what do we always factor before we factor anything else? Say again? Factor the GCF. That is correct. So do you notice how there in my first step I've done that? I factored the 5 out that was in common, and I factored the x out, also in common. Are you comfortable with that? Do you look at that and say, oh, yeah, that's logical? Or do you look at it and say, is he speaking Korean? What's going on? Really self-reflect for a second. If that makes sense, great. If you're just looking at me thinking, I don't even know what he's talking about, that's a problem we need to address, right? It's my problem. It's everybody's problem. We need to work together. All right, so nobody's saying anything. So here's another way to do it. It's a little bit different from the way that I presented it in my work. Once you have an expression factored, can't you set each factor equal to 0? Right? Remember the 0 factor property that says if the product is 0, you can set each of the factors equal to 0? So check this out. What if I just did this right now? If I said 5x equals 0, and then I said x squared minus 4 equals 0. This is a little different from how I showed you on my answers, But this is going to work too. 5x equals 0. How do I get the x by itself? Ouch. I sure hope you're just being lazy if you don't know. Come on. How do I get the 5 away from the x? Divide by 5. There we go. You're scaring me a little bit, guys. Okay, so x equals 0. So that's one of my solutions. I should be able to check that and see that it works. The other one, I could do something a little bit different. Instead of factoring x squared minus 4, and what would we call x squared minus 4? If we were going to give it a name, we would say that it's the... You're making me very sad and very nervous for your test. X squared minus 4 is the blank of blank. Not the property of squares. Difference of squares. There we go. So you could factor it as the difference of squares, like I did before in my work. Or you could do this. Couldn't you add the 4 over? And then how would I get the x by itself now if I've got x squared equals 4? Square, not square both sides. I think you said it. Square root both sides. So if I square root both sides, I get x is equal to, what's the unique feature that happens when I square root both sides?
It's plus or minus.
Plus or minus. The square root of 4 is 2. So there's my the same answers that I got before. I just got the other two, the plus or minus 2, in a slightly different way. The first time I did this, I got it using factoring. This time I used the square root property to solve. Either way is fine. Lisa, did I help or hurt? Okay. 1 or 3? 1 or 3? Okay, so have you guys given yourselves a score out of 4? Right at the top of the page, it should say 2 out of 4, 3 out of 4, 1 out of 4, maybe even 4 out of 4, who knows? It's awesome. Whatever it is, obviously, I hope it's obvious, your goal for tomorrow should be that unless you got a 4 out of 4, tomorrow you at least get 1 better, right? And then as we progress through, better and better. Hey, one unique feature about tomorrow I want to let you guys know about is that tomorrow, which is Wednesday, and Thursday is when we start our full review for our Unit 5 test, which is on Friday. Instead of getting 1 review day this week, you actually get 2. So we're going to try to make really good use of this. So a couple of features about the next couple of days. Number 1, we'll be up at the boards and the little whiteboards a fair amount. We will also be, you'll also be given time to do some work on your gigantic WebAssign review. And then thirdly, each day at the end of class, so tomorrow at the end of class, I hope you're listening, tomorrow at the end of class and Thursday at the end of class, you guys will get an opportunity, last like 10, 15 minutes or so, to do a concept quiz retry if you desire. Okay? So the newest concept quizzes for this unit are 15, 16, 17. Okay? So we can make use of that time as well if that's something you need to do. Make sense? We're going to do a little bit of work with quadratics here, and then we'll finish off our day with our concept quiz over the square root property. So if you would, flip ahead to the next page, which is right here. And I want to look at number 1. Y'all understand this is, again, an example of a quadratic, 3x squared plus 5x minus 1 equals 0. So what ideas would you have as far as solving this? What could we try to do? You could try to factor it. So let's try to factor it. What are the, obviously it's a quadratic like I mentioned before. What is a times c?
3.
Negative 3. And what's my b? Okay, so which numbers multiply to be negative 3 and add to be 5? That's a really quick answer. Are you sure?
Yeah.
A lot of other, you know what? The answer is none. We cannot think of, there's no way we can think of any integer values that multiply to be negative 3 and add to be 5. So this one cannot be factored. So factoring is out. We can't use the zero factor property, so that's no good. Yeah, but we're not going to look at that as like an actual GCF that changes anything. Oh, yeah, GCF is always going to be 1 for sure. It's not really going to help us, though. Ray, what do you say?
Add the 1 over.
Okay, so if you do that, there is a method you could use doing that, but it is a big, big mess. Okay? So you guys remember when we talked about that complete the square thing? So Bray's suggestion is leading us towards that complete the square idea. I'm not even going to have you guys do this. I'm going to show you what the steps for complete the square look like. My point, now listen, I don't want you to write these down. My point for showing you these steps is to scare you away from complete the square right now, because here's what it would look like. You can make your own judgment. If I was going to complete the square, I'd need to do this first, and I'd get this. My b is 5/3, so I'd need to cut 5/3 in half and square it, which, believe it or not, is this. I'd need to add that to both sides. Am I scaring you yet? If not, I'll keep scaring you. I added my fractions and factored. Anybody scared yet? You should be. I could throw this at an Algebra 2 student that's seen completing the square more than you have, and they would probably struggle because there's just a lot of hard details in here. And then my final couple of steps would look like this. And then my last step would look like this. How's that for a easy process to get to an answer?
That looked pretty.
Yikes. And I'm skipping some steps too, right? There's a lot of stuff in between the lines. So here's my point for showing you this. I say tongue-in-cheek, trying to scare you. I'm actually trying to convince you that another method is best. Okay? So if a quadratic doesn't factor at all, which this one just simply didn't factor, you can use complete the square, and in certain situations that's not too bad. In this situation, it's pretty bad, right? So I'm just going to make this recommendation that you don't even consider this right now in Algebra 1. Down the road in Algebra 2, you might. I mean, this is far from not doable. This is totally doable, but it's a lot harder than the way I'm going to show you today. So I write down here, based on what you've just experienced, watching me do this with scary fractions and all this stuff, maybe there is an easier way to handle these non-factorable quadratic equations if they don't factor. So what are some things we could get from this? I've got ax squared plus bx plus c equals 0. What are some key characteristics? What do you see with this ax squared plus bx plus c equals 0? This goes back to some of those polynomial properties we looked at back in Unit 4. What are the degrees doing? I'll point out the degrees to you.
Oh, so we're not doing number 1.
Again, I'll say it. I showed you number 1 to kind of scare you into doing what I'm about to show you. Okay? What are the degrees doing? Descending. There we go. So descending degree. The degree goes 2, 1, 0. So descending degree. And then all of the terms, are they on the same side of the equal sign, or are there some mixed around on different sides?
They're on the same side.
Yes, so all terms on the same side. So we have a name for this. This is called standard form. So if a quadratic is in the form ax squared plus bx plus c equals 0, sorry?
Does that say add terms?
All terms are on the same side. We call this standard form. And if a quadratic is in standard form, just like this, we can easily use what we call the quadratic formula. Quadratic formula. Believe it or not, you've already been using the quadratic formula to some degree. Some of the evaluations and some of the functions that we've used have actually been the quadratic formula, so you're actually pretty well prepared for this. So I'm going to show you the quadratic formula. We're all going to sing a song. I'm going to show you one example. I'm not kidding about the song. And then we'll do your quiz, okay? So here we go. The quadratic formula, perhaps you've seen this before. This is a way that you can solve these unfactorable quadratics. So have you ever seen this before? Seen this before?
No.
So, looks very complicated. You've actually done all of it before. If you were to go back and look at an old concept quiz or test, you'd see that I think 4 different times this year, you've actually already done this. So, I've got a couple of things to say about it. Number one, not for your test on Friday, but for a later on concept quiz and a later on test, you'll need to have this memorized. Okay? If you know the song or one of the songs, it's really not that hard to memorize. The classic goes to the tune of Pop Goes the Weasel. If you search YouTube for quadratic formula songs, there are a zillion of them. So if you're more of like a hip-hop, R&B, rock and roll, nursery rhymey kind of song person, there's all different versions of it, and so whatever. Did anybody else know the Pop Goes the Weasel version of this? Anybody learn this in middle school? There's always at least 1 or 2 people. Okay, why don't you hum Pop Goes the Weasel with me? Ready?
I just know the part where it says Pop Goes the Weasel.
It goes, hey, let's do it together. Ready, set, go. Da-dun, 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 da-dun. Okay, let's try that one more time because that was about as sad as it gets. Ready, set, Pop Goes the Weasel, go. Da-dun, 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 da-dun. Sydney, go. Da-dun, da-dun, da-dun. Hey, we're about to sing the real quadratic formula song, and if I look around and I see that you are not singing, we're probably going to ask you to do a solo.
Oh, right. I got you.
So don't be sitting there saying, I'm too cool for this. Mr. Anderson, don't make me sing in math class.
I got it. Yeah.
Well, can you do the quadratic formula with me?
Yeah, Chase.
Oh, no, I was just going to do a sing.
All right, well, here, let's you join me. It's so dumb if I just stand here and sing in front of you. So you try to join me, all right? You ready?
I will gladly join.
Follow along, look at the screen. Here we go. No. Let's start off right. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, Mason, pretty good. Pretty strong there. Okay, let's sing that one more time. We'll do an example, and we'll practice this a bunch more next week. You guys ready? Let's sing together. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, we're getting there. So I'm hoping that while you're sitting there at lunch today, you'll start humming this. You'll be like, oh, the quadratic formula, it's in my brain already. We'll see. Hey, let me show this to you. Then we'll be done. Number 2. Here's how you use this. Number 2 is not factorable. Sorry to say. Number 2 is not factorable at all. And so I would recommend for you guys the quadratic formula. Here's how you go about this. You'd want to identify your A, your B. Hey guys, like you said, this is complicated. Pay attention. And your C. So what's the A value? No, just 5. The A value is always just the number. It never includes the variable. What's the B value?
4.
And the C?
2. Negative 2.
Got to include the sign, so it is negative 2. And the quadratic formula, maybe you hum it. You're like, x equals negative b plus or minus squared. B squared minus 4ac all over. Maybe you have to hum it or something. Maybe sing in your head, whatever. And then it is exactly what you think. The 4 goes in for the B's. The 5 goes in for the A's, and the negative 2 goes in for the C's. It's just a matter of plugging in. So, this would be x equals negative 4, that's right, plus or minus. What's 4 squared?
16.
Minus, what's 4 times 5 times negative 2? 4 times 5 is?
20.
Negative 20.
No, 4 times 5 is 20. What's 20 times negative 2? So it's 16 minus negative 40, which ends up being plus a positive. 2a would be 2 times 5, which is 10. So I've plugged everything in. I just need to simplify a little bit. This would be negative 4 plus or minus square root of 56 over 10. Square root of 56, is anybody good at these radicals? Do you know how that simplifies? 2 square root of 14, Sasha, well done.
Good job, Saj.
So plus or minus 2 square root 14 over 10. There's a little bit more simplifying we could do with this, but if you got to a point like that, then I think we'd be good. And who on earth is going to guess that for an answer? Nobody. You really have to use the quadratic formula to get to an answer like this. Okay, if you guys would please build a fort. Get you started on your concept quiz 18.